So you should notice that the spreads tend to increase faster with maturity for low credit ratings than for high credit ratings. For example, the difference between 5-year spread and the 1-year spread for a BBB rated is greater than for the AAA rated bonds. Okay? Here is another diagram that illustrates this idea that usually the spreads are increasing, but the differences are getting bigger and bigger once you have low credit ratings. So starting from AAA, AA+, AA minus, A plus, and A. Then for the lower credit ratings, which are the A in this example, the difference between low credit rate, low maturity, short maturity, and a long-term maturity, the difference is bigger than for high credit ratings like the AAA. Let's learn a little bit about expected default losses on bonds. The present value of the excess yield, the extra yield of the corporate bond over the risk-free bond, which we measure it from treasury bonds, reflects the investor's compensation for the default risk, for the credit risk. This is the same as the extra return, the extra excess of price of the risk-free bond over the corporate bond. Always remember that higher price means lower return in bonds. Now, in order to calculate the expected default losses on corporate bonds of different maturities, we need to compare the price of the corporate bond with the price of a risk-free bond with the same maturity. We need to match them based on the same maturity, the same time until maturity, and the same coupon rates. Usually we take the treasury bonds as the risk-free assets, US treasury bills, notes, and bonds, but this causes a problem since the treasury bond and the corporate bonds involves different taxes. In the US, just to let you know, treasury bonds are not taxed at the state level, while corporate bonds are taxed. Therefore, in many cases, we compare it to the LIBOR zero curve. LIBOR zero curve is a term that represents the LIBOR interest rates, the London Interbank Offered Rate. This is the interest rate that banks lend to each other, and the clearing house, the clearing market is taking place in London. That's why it is called the London Interbank Offered Rate. And the LIBOR zero curve represents here the risk-free zero curve. Okay, just a different benchmark as opposed to the US Treasury bonds, simply because it is taxed also. So here is an example. The following table presents how to measure the default loss. Okay, let's say we have different maturities starting from 1 year, 2 years, 3 years, 4 years, and 5 years. Risk-free zero rates. Those are the 5% all the way. Corporate bonds, zero rates. And then the gap is simply using those numbers. Let's see how those calculations are taking place. Let's see how we figure out the fourth column, the expected default losses. Okay? The calculations are as follows. The value of a 1-year risk-free bond with a face value of $100, let's discount it to present time using the continuous discounting method, which means let's multiply times e to the power of minus RT. E is the base of the natural logarithm, which is roughly equal to 2.718. R is the risk-free interest rate. In this example, it was 5% over 1 year. Here is the 5%. And T is 1, because this is a 1-year risk-free bond. So whenever we multiply the future value of $100 times e to the power of minus R, R is 5% risk-free interest rate, and T next to that is 1, so we can simply ignore that. So E, like I said, is the base of the natural logarithm, 2.718. Do the math and you will get that this is equal to $95.1229. This is the value of a 1-year risk-free bond. The value of a 1-year corporate bond will take the same $100 par value, but then we will discount it with a different interest rate. This is not the risk-free interest rate. This is already the discount rate that is applicable for the corporate bond. The 5.25% is taken from here. This is the zero rate for the corporate bond. We are usually increasing the interest rate over the risk-free zero rate simply because it is more risky. So using this discount rate, or if you want the yield or the yield to maturity for that bond is higher than that, so we'll take this as the appropriate discount rate. When you discount $100 future value back to present time using the continuous discounting method, which means multiply times e to the power of minus RT, you will get $94.8854. So the present value of the loss from defaults is the following. On this corporate bond is the gap between them two. The gap between them two is the present value of those defaults. It is 95.1229 minus 94.8854, which is roughly speaking 24 cents. It is $0.2375. This is the present value of the loss that is expected from the default. What it also means is that we expect almost 24 cents relative to a price of 95.1229, which is the present value of the risk-free bond, which is about 0.2497% of a no default value of the corporate bond to be lost from defaults. We're taking the amount, the gap, and we're dividing it by the risk-free bond. This is the proportion out of the risk-free bond that is allocated simply because of the risk of default. This is how we got the number 0.2497%, which is written here. So the same thing we do again and again. You do present value of the $5, present value of the $5.50 for the 2 years, and then we divide it by the respective price, present value of the bond for the risk-free treasury bonds, and this is for 2 years, so you need to raise to the power of 2 the present value, and this is how you will get this percentage of no default value, and so on and so forth. Let's learn how to calculate probabilities of defaults assuming no recovery. No recovery, it means that even if there is default, we will not be able to liquidate anything, we will not be able to squeeze anything out of the corporation that has defaulted. Later on, you will see that a more realistic assumption, we are going to assume that there is some recovery. Because even if a corporation defaults, simply because of the higher priority to liquidate the asset, it always goes first to the debt holders, and then and only then the shareholders will get something pro rata of whatever is left after distributing the assets to the debt holders. Then usually there is some recovery. Now, roughly speaking, recovery in many cases, it is roughly speaking anywhere between 35% to 45%. So even if a corporation defaults, you will still be able to get something out of the debt. You're not going to wipe out 100% of the debt, you will get something. This is called the recovery. And recovery rates usually range between 35, 40, 45%, usually. This is real statistics. But let's start our story with, let's calculate the probabilities of default, and let's assume for now that there is absolutely no recovery. If the issuer will default, you will get nothing out of that. So let's define the following. YT will be the yield on a treasury year corporate zero coupon bond, where the treasury year really depends on the year. If it is a 1 year, it is a treasury bill. If it is 10 years, treasury notes. More than that, treasury bonds. Okay, for specific years. Y star T will represent for us the yield on a T-year risk-free zero coupon bond. Okay, so this will be the benchmark, the risk-free interest rate, while YT is the yield on the T-year corporate zero coupon bond. And QT for us will represent the probability for corporation to default during the period from now until time T. So this is the domain 0 until time T. Okay? The value of a T-year risk-free zero coupon bond with a face value of $100 is, let's discount it using the risk-free interest rates, Y star T. So let's use the continuous discounting method. Let's multiply the future value of $100 times e to the power of minus the interest rate times T. The interest rate here is Y star T, and t is the remaining time. While the value of a similar corporate bond, we're going to simply discount it by the interest rate of yt. Okay, yt is associated with the corporate, y star t is associated with the risk-free. Every time we're using the continuous discounting method.